All right, in chapter 11, we're going to go back and review some stuff from Algebra 2, exponential and logarithmic functions. If you recall, these two are, again, are inverses of each other, meaning we use one to undo the other, and we will look at that more and more as this chapter continues. But this first week, what we'll do for the most part is just deal with our exponential idea. And when we talk about in section 1 real exponents, they have properties of exponents. So suppose m and n are positive integers, a, b are real numbers, then the following properties hold. Now, a couple things. You got to remember your negative exponent rule. That's why they talk about a and b being, or I mean m and n being positive integers. Okay, what we're talking about is when I take a power. Okay, again, in power you have a base, and then you have an exponent. A lot of times they'll call that as a power. Okay, if I have two bases, or two powers that have the same base, and what I'm going to do is multiply them, I call it the product property. What we do to simplify that up is to simply add my exponents. And I talk about a lot of times is taking a step down the order of operations. And again, your order of operations being parentheses, then you got your exponents and radicals, and then you have your multiplication, division, addition, subtraction. So when we talk about exponents, what we're doing is we're taking that step down from multiplication, we're going to step down to addition. Okay, so one thing to bring up is that in this example here, notice that my base is 16, it stays 16. It's a very common error that people will multiply the 16s together. From there, generally, I'll jump to the quotient next, because that's similar, because product, quotient, multiplication, division kind of go together. And if we have the same base again, which is one of the things we always have to look for, now I can get by with subtracting my exponents. And again, so I'm saying we're taking a step down from division down to subtraction. And again, a, they say can't be 0 because that would put 0 in my denominator, which is an undefined operation, of course. Same idea. This does not go to 1. If we have like bases, we keep that base again. Okay, so be careful with that. Next one, we go to power of a power. So I have a power, a to the m, and I'm going to raise it to yet another power, the n. Okay, so I consider that kind of like, well, that's an exponential piece, so I'm going to take a step down, and that means I'm going to multiply my exponents. Okay, so in this example, 9 to the third raised to the second, multiply my 3 and 2. All right. Next, we have power of a quotient and power of a product, which are both fairly similar. I talk about how they're both in grouping symbols. And what we basically do is anything that's inside the parentheses and it's being raised to a power, everything gets raised to that power. So my numerator gets raised to the power and my denominator gets raised to the power. Okay. Down here, both the a and the b get raised to the power. And this is a great example. Okay, a lot of times what people will do is they'll forget to raise the 5 to the third power, okay, but we do have to raise both pieces in there. Okay. A couple of other little things that will come up in here are in this example. Okay, obviously anything raised to the first power is that number back. Okay. What it means again to be an exponent is whatever my exponent is how many times I'm going to multiply that base times itself. And another big one for us to take care of and remember is that anytime something is raised to the 0 power, it's going to be equal to 1. So I don't care how big that number is, if it's taken to the 0 power. Another classic trick that people will pull on you is you'll do something like this, where you'll have a whole bunch of stuff in parentheses. And then all of a sudden they'll say, hey, what's it all to the 0 power? It's 1. And probably the biggest one that we struggle with right here is the negative exponent. Okay, and the thing is that I know how to take 2 to the third. That means to take 2 times itself 3 times. But I don't know how to take something times itself a negative 3 times. And it's fairly easy to show using a couple of our earlier properties where this is going to go. So if I said that, well, maybe I got that by taking 3 minus 6, okay, working backwards using my quotient rule. Well, and then that's 2 to the third over 2 to the 6th, and if I simplify that out, what I end up with is 1 over 2 cubed. Okay. So I always talk about if you have a negative exponent, it's on the wrong side of your fraction. move it over, and there comes that idea again of changing sides, changing signs. Okay, and so I use that a lot of times, and many of you heard me say that quite often. Just going to look at a couple of quick examples here. Obviously, some of these are fairly simple. Since this is all multiplication, keep your base, add your exponents, done. Okay. Now, when you get to some fraction pieces, break it into parts. Okay. What I'm going to do is first simplify, and I'm going to put the negative up in the numerator. I'm going to divide a 3 out of 12 and a 3 out of 9 to first get the number piece taken care of. Then I'll deal with, okay, I got m to the 8th over m to the, and again, you got to remember it's to the first there. I'm going to deal with those. Okay. Now, definition says 8 minus 1. Okay, and I like to talk about where do I have more m's, top or bottom, because that can sometimes make it a little easier in terms of if I subtract and got a negative and bouncing things around. So I have more m's up top, and then I'm also always going to be able to take big minus small, so 8 minus 1. Okay. So then finally, you got your y's, more on top by 2. Example like this one, number 10, one of the things you want to do first is get rid of your parentheses. And so you got power to a power, so what I'm going to do is multiply my exponents again. Got to raise a 2 to the 3rd power as well as the x to the 6th, or x squared to the 3rd. And again, same type of idea. I can take a 2 out of each of those. I'm going to take care of my number parts. Now, because I have a negative exponent, I move it to the other side. Okay, change sides, change signs. Now it's positive. And so again, one of the things I'll talk about is that, hey, I got 6 x's and 12 x's, so altogether I have 18 x's. Okay. Here's that example again where that whole piece is going to go to 1 because of the 0 power. Done. That quick, that easy. Okay. Situation down here. Before I do anything with it, I'm going to move things around to get my exponents to all be positive. And then I'll deal with it. So 2 cubed is 8, 6 squared, 36, 4 and 3, so I got 7 x's up top. Simplify your 8 and 36. You can take a 4 out of both of them. And we're done. All right. Something that is going to be new, though, is our rational exponents idea. They start out by talking about your definition to take b to the 1 to the n, or raise it to the 1 over n power. And what that simply means is that's going to be your nth root. The most common situations, if I have something that's raised to the half power, we're talking about the square root of that number. Okay. Now, a couple things. B has to be greater than or equal to 0. Okay, so we can't deal with our base being negative. N has to be greater than 1. Okay. If b is 0, n has to be odd, because we can take cube roots, fifth roots, and whatnot with the odd numbers or odd values. So then they get to the definition of rational exponents, and they say if I have b over m to the n, well, we just got done seeing that your denominator becomes your root. Okay. Your numerator stays inside with the base, or sometimes it's easier to take the nth root first, and so what they're really doing is they're kind of doing this. They're saying, hey, 1 over n raised to the m power. Okay, so you'll get better with that as you look at some examples. Okay, and so a couple things that they'll do is express using radicals. So I got a denominator that's 3. Okay, so that's become my root. So x to the first, y to the second, our numerators come in here. Now, if they did do something like this where they said x to the 1/3, y to the 1/6, the first thing you would have to do is get it so that you have a common denominator. Sorry there, that should be a 2/6. Okay. Because I need that common denominator so I have my root. I don't want to write it with 2 separate radicals. Okay. Right, using rational exponents, so remember that's a 2 there. It's implied once the square root that that's a 2 there. So I got a 4, exponent is 1, so the 1/2. Okay. A, numerator over root, or power over root. 5 over 2, and then simplify it down anywhere we can. Now, like I said, there's your square root. 6 divided by 2, and leave them as fraction. Okay. All right, and so that's where this can come into play with some of these problems now, is when I come in and look at simplifying them down, you know, I want to look at the 5th root of 32. Okay. Well, that's something that you could type into your calculator, or the other thing that we can look at is that's 5, and then what I look at with 32 is that's 2 to the 5th, because then that becomes 2 to the 5th over 5, or just 2. Okay. All right, I think this shouldn't be too bad once you get going with this section, so good luck with that, and we'll get the next one up here.